5/8. So we have to integrate 4 to the x. And one of the rules is if it's b to the x dx, since the base is not e, which would then be just e to the x, it's b to the x. And if you change this to e to something, it becomes an ln. So you have an lnb. That's the rule for a base other than e. You have to divide by the ln of that base. So the integral of this would be 4 to the x over ln 4. And we're evaluating from 0 to log base 4 of 3. So this would be 1 over ln 4 times, if we put this in for the power, 4 to the log base 4 of 3, the 4 to the power and the log base 4 cancel each other and we get just 3. And then if we put in 0, we get 4 to the 0, which is 1. And so we get 2 over ln 4. Okay, now this has got a negative on it. Now this, if it was just a positive, it would be x to the 7th over ln 7. But it's got a negative on it. What does that do to it? Well, if you took the derivative of this, it's going to have this on here, but then it's going to be times the derivative of the inside, which should produce a negative. And we don't want that negative, so we have to put a negative on this. Or you could, in other words, let u equal negative x, and then du would equal negative dx, and that would create the negative, and you'd have the integral of 7 to the u du with a negative, which becomes 7 to the u over ln 7, and we have the negative on it, and then we'd put the negative x back in for the u. Okay. This one is a bit tricky. We need to get these both in the same base because we can't split this up. These are multiplying, not adding or subtracting. So since 2 is e to the ln 2, then 2 to the x would be this to the x, and if you multiply powers, they can come down. I mean, if you got a power to a power, you multiply them. So this becomes the integral. 2 to the x becomes this, e to the x ln 2 times e to the 4x dx. And when you're multiplying, you add the powers, so we have x ln 2 plus 4 times x. We can factor out an x, and we get x times 4 plus ln 2. So this becomes the integral of e to the x times 4 plus ln 2. Now that's just a constant times this, and we've learned that the integral of e to the kx dx is just e to the kx over the k plus c. So that's our constant, so this just becomes e to the x 4 plus ln 2 e to the kx over the k. This one, we're going to let u, since we got adding and subtracting the denominator, and it's the more messy, so I'm going to let u be the x squared plus 4. So du equals 2x dx, so dx is du divided by the 2x. So this becomes 3x plus 2 over u, and the dx becomes du over 2x. Now, this x can't cancel that because these are added. So we're going to split this up into two of them. Integral of, that's not going to be so pretty. This is going to be 3x over u times 2x du plus the integral of 2 over u du over 2x. These cancel, but this x is still there. This one, the x's would cancel. This would be 3 halves ln u plus this one. With that x still in there, we're going to have to solve for x, and that would be u minus 4 square root is is x. And I don't want to do that one here. And this one would involve a trig one that we didn't talk about. So I'm going to tell you to skip that one. 51. All right, on this one, these are subtracted, so we can split these. This is going to be the integral of e to the negative x dx minus the integral of 4x dx. This with the negative on there is just e to the negative x with a negative minus, and 4x integral is 2x squared, because this becomes x squared over 2 and the 2 is reduced. And that's it. This one, if you let u be e to the x, the first choice might be to do this one, but it gets ugly. So the second choice might be to let u be that, so then du would be e to the x dx, and so this would become the integral u parenthesis, this would be u squared, because this is like e to the x to the 2, so u squared, plus 1 to the third, and du, dx is du over e to the x, which is a u. And so then I can cube this, and so I take u squared plus 1 times u squared plus 1 times u squared plus 1, and that comes out to be u to the 6th plus 3u to the 4th plus 3u squared plus 1. And so we have to integrate that, which is u to the 7th over 7 plus 3u to the 5th over 5 plus 3u to the 3rd over 3 plus 1u plus c. And then we can put e to the x back into this. So this becomes e to the 7x, because e to the x to the 7th, you multiply the powers, plus 3/5 e to the 5x plus e to the 3x plus e to the x plus c. And 65. Cotangent is cosine over sine. So I'm going to let u be that denominator. If I let it be the numerator, it's not going to cancel anything. But if I let it be the denominator, then du would be cosine x dx, and the cosine will go under the du. And there's going to be a cosine that cancels. This will become the integral of cosine x over u times du over cosine x. And so we have the integral of 1 over u du, which is ln absolute value of u plus c. But u was the sine x, so it's ln of sine x.